Hi, my name is Vladimir Korikov, and in this module we will start using the Fluent Validation Library to validate input requests in our application. We will discuss various features of that library and we'll see how they help us simplify our validation code. We will start off by extracting this validation logic around the name property. For that, we first need to install the Fluent Validation Library. Installing it. Good. In Fluent Validation, all validation rules are stored in separate classes, so let's create one. This class is going to validate registration requests. I'm calling it Register Request Validator. Inheriting it from the abstract validator, this class comes from the Fluent Validation library and provides all the functionality needed to create our own validators. Let me rename the file so that its name matches the class name. Validation rules themselves are defined in the constructor. Here's our registration data contract once again. We will work with the name property for now. We'll take care of the other two later. And here are the validation rules once again. To re-implement them with Fluent Validation, we just need to call the rule4 method, pass the expression that tells the library which property we are validating here, and then specify that this property should not be empty and that its length should be between 0 and 200 characters. Let me comment all these checks so that they don't interfere with our testing. To use the validator, we need to instantiate it and call validate. I'm passing the request as an argument to this method. If the validation fails, we return a 400 response with the error message of the first error in the validation result. Let's test this. Running the application. In our registration request, I'm replacing Carl's name with a null and sending the request. And you can see that the API has successfully returned an error saying that the name property cannot be empty. And this time this error has a proper 400 response code, which tells us that it's the client who made a mistake here, not the server. Note that if I change the name from null to an empty string, the registration request succeeds and creates a new student with ID 3. That's because in the validator, this not null rule only catches absent strings, or strings that are explicitly set to null. It doesn't prohibit empty strings. To prohibit both nulls, empty strings, and white spaces, we need to use the not_empty rule. This rule checks for multiple conditions, including nulls, empty collections, and strings that are empty or contain white spaces only. Let's run the application and test it again. Very good. Now the validator catches the empty string as well. And to verify that our application doesn't accept strings longer than 200 characters, let me copy these 10 characters several times. Sending it. Very good. The validator caught it as well. It even told us the current length of the string. Alright, that was the first property, name. We can now remove the corresponding naive validations from the controller. Let's do the same for the remaining two properties, email address and address. The rules for the email address are going to be similar, except that the length is going to be 150 instead of 200 characters. To check that the string is a valid email address, we can use this method. It accepts a flag that tells Fluent Validation which email validation rules to apply. This flag was introduced because there was a change in .NET in how the built-in email address attribute works. The .NET Framework version 4 used this huge regular expression to check the email correctness. The .NET Core, on the other hand, now uses a much simpler set of rules. Those rules are equivalent to this regular expression. It's basically just a check that the string contains the @ sign and that this sign is not the first nor the last character in the string. The .NET team has introduced this change because in practice it's impossible to verify the email address correctness with a regular expression. That's because different email servers impose different rules on email address validity. The only reliable way to verify an email address is to send an actual email message to that address and then ask the user if they received it. And since no regular expression, however complex it is, can do this job, you might as well simplify that regular expression to free yourself from additional maintenance burden, which is exactly what the .NET team did. By default, this method uses the validation rules of .NET Core, so we can leave it as is. Finally, there's also the address property, which has the same validation rules as the email address, except for the regular expression part. Very good. Let's run the application. Let me first check that the non-empty requirement was successfully applied to the email field. And it indeed was. You can see that the API has returned a proper error message. And if I remove the @ sign, the API correctly recognizes this email as invalid. And the same for the address field. The API doesn't allow us to set it to an empty value, such as null. Let's remove the corresponding naive validations for the email address and for the physical address. Good. We will skip these more complex validation techniques for now. We'll talk about them later in this course. In the previous demo, we used Fluent validation to validate simple properties. In particular, we have validated the name, email, and address properties of the register request. In Fluent validation, all validators are created in separate classes, like our register request validator, and all validations are defined in that class's constructor. Notice how we chain different validations together on the same property. This style of programming, where each method returns an object that we can use to make further method calls, this style is called the Fluent interface pattern, and it's great for code readability. That's where the name of the library, Fluent Validation, originates from. Notice a couple of important things in our validator. First, this validator validates the registration request, not the student class itself. You should never use Fluent validation for checking your domain classes, because that would mean you're using those domain classes in place of data contracts. We will talk about it in part 2 of this course, when we'll be discussing always valid domain models. You can also refer to my course about anemic domain models to see an example of this anti-pattern. Second, notice that we've called our validator register request validator, not register validator. These two names look similar, but the difference is important. We're not using our validator to verify the registration functionality. That's the responsibility of unit tests. We are validating input, which is the register request, the data that our API receives from the outside. So name all your validators after the data contracts you have in your project. In our case, the data contract is called register request, but you could also call it register DTO or register model.